Okay. Hi guys, Emil, it's me. I'm gonna share with you some stuff about Olga and I. Many of you know this. Olga and I got married. Olga is my wife. 12 years. We met in Los Angeles. She came to a training that I was giving. I was doing training for teachers in LA Unified, and she was one of the people who came to the training, and we got to talking, and a year later I asked her out, and we moved in and got married. So it's been a wonderful marriage. About 5 years ago, Olga unfortunately started to feel some numbness in the right side of her body, and we didn't know what it was, and so we took her to the doctor, and of course after quite a bit of testing and MRIs and CAT scans, and they discovered what's called a cavernous malformation in her brain. So a cavernous, it's basically some capillaries that are just sitting there. Basically, it looks like a little raspberry in her brain. And it's called cavernous because it was in the middle of her brain. It was actually on the stem of the brain. So she had that excised, but because of the severity of the operation, major brain surgery, not just a little brain surgery, it thankfully was quite successful, but it was sitting, the malformation had to be excised from the stem. And so apparently there was some central nerve damage, because she did suffer a little bit of a paralysis in her lower brow. So, causes some minor blurring, double vision and things of that nature, which we compensate for. But she got to experience what's called neuropathy. And I learned about neuropathy, which I guess it's just nerve pain. It was going all up and down her right side of her body, and we just assumed after consultation with pain experts and the surgeon and other folks that, it's just neuropathy that came as a result of, a pretty serious brain injury. But, she takes some medications and she's able to handle it, and she's gotten used to it and copes with it, and, we've been doing well. Unfortunately, though, the hits just keep on coming. So, a while ago, she started to feel a little bit of weakness in her right hand, and so we just assumed, okay, well maybe there's some, that's what happens when you suffered. This was her brain surgery was 5 years ago, so that's what happens when you have major brain surgery and you have neuropathy. 5 years of pain in the right side of your body, it's probably going to damage your body and your nerves somehow. And so we took her to a specialist to see, shoot, maybe we can get this nerve taken out or something. What's happening? Why is it getting worse and worse? And so they did some testing and did a blood panel on her, and still couldn't figure out what was going on. I mean, we went to all over the place. We saw a whole bunch of different folks about it, and then her Kaiser neurologist called her and said that he wants her to go take what's called an EMG, or I think it's electromyography or myogram or something. So it's a muscle conduction test where they see how are the muscles interacting with nerves. And I didn't know, I didn't think anything of it, just another test. Great, maybe he has some theory, he thinks he knows what's going on. One of her doctors sent us some interesting information about a syndrome called chronic regional pain syndrome, which met her exact indicators. All of the things that she was presenting, met it perfectly. So we said, that's what it must be. It must be chronic regional pain syndrome. So then her doctor called her and said he needs to see her about the results of the exam. So when we got to the doctor's office, they did another exam on her to see what's going on with her muscle and her musculoskeletal system. She was showing some weakness on the right side of her body, of course, because, well, that's what the problem was. That's why we were there to see. But he did an exam again, and then he had us both sit down, and he he went over some stuff and said the bottom line is that he and his colleague believe that my wife has amyotrophic lateral sclerosis. Those are, you can probably tell, bad words. So amyotrophic lateral sclerosis. So amyotrophic meaning muscular, and lateral meaning upper and lower motor neuron. And I, suddenly learned quite a bit about neurology, so I can tell you a little bit about that. And then sclerosis, the deadening. It's Lou Gehrig's disease, basically. And basically the doctor told her she has 2-3 years left. And that she should quit her job immediately, apply for disability, get your affairs in order. Basically saying, all right, love the ones you're with because this is all that's left. There's no cure for ALS. There's no disease. There's 2 treatments. And if they work, they may extend your life by 3 to 9 months. They mostly say 3 to 6, but it's incredibly expensive stuff, and insurance companies eventually don't even cover it. And the fact is, in some people who have ALS who take these FDA-approved drugs, it actually increases the progression of the drug. So, the disease. So what is it? It's basically, what's happening is that, so when I'm not a psychologist, but I like the stuff. So I've read a lot about it over the years. So definitely don't take my word for it. But this is, I think, what's happening. This is what is happening. So you have a desire, right? You say, I want to touch that flower, right? Well, okay, better. I want to touch that box. I want to touch, I don't want to touch anything, all right? But I want to lift that cup. How about that? Let's just keep it nice and... So, I want to pick up that cup, right? So, there's some weird stuff that happens, right? But generally speaking, the thinking is that the brain then says, okay, we need to send a signal. So the brain then sends a signal via what's called the upper motor neuron. And that connects, it's like a long, just think of it as a wire, connecting the brain to the spinal cord, right? The big long thing. And so then you've got other nerves coming out from that spinal cord that go out to your arms and legs and, all the stuff that happens in the rest of your body, right? And those nerves travel along what's called the lower motor neurons. Those are the lower motor. So upper motor to the spine, from the brain to the spine, lower motor from the spine to the everything else. So if you want to pick up the cup, the brain sends a signal, right? And then that hits the spinal cord, and then the spinal cord goes, oh, okay, in order for that action to occur, I need to send a signal down these lower motor neurons so that the arm can actually grip the cup, pick it up, and come over and drink it. Now, there's actually, before I go further, one of the things that I learned many, many years ago, interestingly enough, having some fascination with this field, That's probably a whole nother video. They've done tests on that exact process that I was saying. You have a desire to pick up a cup, the brain sends a signal to the spinal cord. Well, it turns out that, from what I recall, what they're basically doing is they're timing how fast it takes for you to have the thought and for the brain to send signals to the motor, to the central nervous system, and then the central nervous system pushing out to the rest of the limbs, right? And what they discovered is that you would think the sequence would be desire, brain creates signal, and fires signal. But that's not what happens. This is what happens, apparently, according to some researchers in UC San Diego, is that it goes like this. It goes, the brain creates a signal, fires it, and then you have the desire to tell the brain to send that signal. So literally, the brain apparently knows that you want to pick up the cup before you know you want to pick up the cup. Anyway, so what ends up happening after you send that signal is you grab the cup. Well, with amyotrophic lateral sclerosis is that those wires are cut, right? Basically, it's like imagine you have a marionette, you got a little puppet, right? And you got strings attached to the little puppet that's dancing, and you are the brain in this metaphor, and you want to tell the marionette, okay, move your head this way, and you move your hand, but the strings are not attached. So you're sending a signal, but the head is not moving. And eventually, when the signals aren't going to the muscles go, hello, we're here. What's going on? What are we supposed to do? And there's no signal coming back, so they start freaking out, right? So they start doing these things first called fasciculations, which is they start to spasm, and then they go into serious spasms, and eventually atrophy, and then the muscles die. And as the muscles die, you lose functionality. And as you lose functionality, eventually, you're confined to a wheelchair, and, it spares your eye muscles for some reason. It's interesting. But every other muscle over a period of time starts to die, and as the muscles die, you lose functionality, and eventually your head, throat, because these are muscles right here, right? And so these muscles have to work for you to be able to swallow, your spittle and the whatnot. And so it becomes difficult to swallow, and eventually you start choking on your own spittle, and then eventually your diaphragm, which is the muscle that lets us breathe, also starts to denerve. So needless to say, our lives have changed completely, right? It's the stuff of movies, right, and plays where, you're in an office and somebody tells you you've got a few years left to live. And it's amazing how people react in those moments. And it's usually not at all how you think you would react. And sometimes it's exactly how you think you'd react. But it was quite an experience. So, where do we stand now? So in the wonderful world of ALS, there are levels of diagnosis. This is the problem with ALS, is that it's hard to diagnose. Most of the time it takes 6 months to a year to even diagnose it and say it's ALS. Because it could be a lot of things. It could be metal poisoning, Lyme disease. It could be this thing we thought Olga had, this complex regional pain syndrome. It could be a lot of different kinds of things, right? It could be muscular sclerosis. It could be, multiple sclerosis. It could be muscular dystrophy. It could be a bunch of neurodegenerative diseases. It's hard to determine whether it's ALS or not because there's no such thing. There's no biomarker. Well, not yet. I think I have maybe in a future video I'll tell you all about it. But technically, officially, there's no biomarker. And it basically means that there's no way to know, you can't test for it. You can't draw blood and say, oh, look, that marker is past this number, which means he probably has this or she probably has that. There's no indicator. And it's hereditary in 5 to 10% of the population, and 90% of the population, or what they call, who get ALS, is called sporadic, because there's no freaking way of knowing why it is that they got it. But for 5 to 10%, they have identified a couple of genes that, if you have it, the likelihood of you getting ALS is going to be higher. Interestingly enough, ALS also seems to be in higher incidence with the military, the men and women of the military, as well, interestingly, as American football players. And I have a lot of thoughts about that too, which I'll be sharing with you in the future. But so we don't know what the hell is going on with this thing. And there have been trials and drugs and methods and procedures, and there's homeopathic remedies out there that, in fact, many of them are really interesting. And but there's no cure, that we don't know what's happening, or you can't cure something if you don't know why it's happening. And they haven't been able to figure it out. They still haven't been able to figure out what's going on. It's very interesting mystery, obviously. So, obviously, you can imagine if this would happen to you, you would be reeling from the shock. I'm sure you can. Nobody takes this sitting down. Some people react differently. I heard about a family that got the diagnosis from their doctor, and they had a conversation with the doctor, and they said, ALS, that's the one, but there's no cure for ALS. And the doctor said, yeah, there's no cure for it. And they said, okay. And then they all got up and they went out into the lobby, and nobody said a word, and they just opened the elevator. Everybody apparently got in the elevator, went down. Nobody said a word, and they got outside the doctor's office and said, what do you guys want to do? And they go, let's go to lunch. And they went to lunch because, what do you do? There's nothing to do. There is no alternative. There is no cure. It's basically a death sentence, but not now, not immediate, over a period of time. So, so you either get busy living or dying, right? So, we're going to do the living thing. So, I put my digital literacy skills to use. Sorry, those of you I work with might get a little chuckle out of that, but, got into it, man, to find out what can we do. And I have some fantastic news that there is some a real solution. I used to say there's real hope. It's not hope. It's an actual solution, because I think we're this close. Here's what's happening. There are 2 treatments available for ALS patients. One is called Rilutec, or Rilutec, or something like that, and that's a pill you take. And then another one is called Radicava, right? So the pill thing, the Rilutec thing, which has multiple names, came out apparently a couple years ago, and first of all, it doesn't work for everybody, and for the people that does work, it basically expands their life, minimally, like maybe 3 months or so. But then about a year ago, the Japanese did some clinical trials with a new product called Radicava, which again has multiple names, but they did clinical trials with all Japanese people, and they say, look, man, it's working. We're able to extend life, 6 months on average, 3 to 9 months, basically. And the FDA fast-tracked that little sucker. So we went through its phase 1 trial, which was basically to prove that it's not poison. It's not going to kill you. And once it started its phase 2 trial, the phase 2, which is to see whether, if it does what they said it does. So basically it went from 0 to market in 6 months. I think that's the timeline. I'm probably wrong about the exacts of that, but it's something in that range. So what I'm trying to say is that the FDA was able to do something about fast tracking something that was able to extend life for, people that are, trapped in their own bodies for just a couple more months, right? Which is better than nothing as far as I'm concerned, Same thing apparently happened in the 80s and 90s. When the AIDS epidemic was happening, the major drug cocktail that came out, and again, I might be wrong about my facts, so please let me know. I think it was called AZT, and it was working for a majority of the people that contracted HIV, but not for all of them. And then a whole bunch of new drugs were developed, and if I'm not mistaken, there was a drug that came out, and I can't remember what it was called. It was Stuve or something. I don't know. I'll find it. But that was working for the other 20% of the people that AZT wasn't able to support. And so the FDA, again, put it on an alternative track. So they do have investigational tracks. The FDA says, yeah, we're not going to, if we see that there's a drug that passes phase 1, meaning it's not poison, it'll be fine, and we can see that there's some, even though phase 2 isn't necessarily designed specifically to see whether or not the treatment is efficacious or not, but at least we can see, hey, look, it's working. Why would you not let people who have a terminal disease who are dying anyway sign away and say, look, if it kills me, it kills me. I'm dying anyway, and try it, right? And so, that's what happened with that, and apparently it worked out really, really well. So, why am I telling you all that? Here's why I'm telling you all that. It's because there is a company out of New York and Israel. Their headquarters are in Israel, but they do much of their work out of New York and California, interestingly, and it's called Brainstorm Cell Therapeutics. And these guys and gals, small company, 35 people, have potentially discovered something that's about to change the world. This isn't quackery. What I'm telling you about now is not quackery. There's a lot of quackery. This is not quackery. Yes, it is stem cell information I'm going to tell you about, but it's not quackery. It's legit. It's legit. And I'll explain the whole thing. What Brainstorm has done is that they've developed a technology, what they call a technology platform called Neuron. Neuron, like neuron, and then own, like my own body, my own cells. Neuron, my own neuron, my own, Jesus, all right, settle out, neuron, that's what it's called. So, and here's what it is. It's a technology that allows the hospital to drill into your hip, yeah, and aspirate bone marrow, which I believe is a process where there's some air, or I don't know what they do. I think aspiration is about breathing, so I'm assuming they're pushing something in there, whatever it is, or pulling something out, whatever it is, they're getting what they call mesenchymal stromal cells. Yeah, it's a beautiful word, isn't it? Mesenchymal. Let me say it again. Mesenchymal. Mesenchymal stromal cells are basically just like adult stem cells. They're not embryonic cells, right? They're your own adult stem cells. And if you know stem cells, they're types of biological things in our body that grow things, right? So we have cells and we have stem cells, and those stem cells create cells. They're like the stem or the birth or the generation of cells, right? So stem cells kind of like say, look, here's the pathway you need to go, rest of you cells, and for you ear cells, you got to go this way, right? So stem cells kind of set the pace and the direction for cells to develop into body parts and things of that nature. So they take that stuff and they put it through. They take your own stem cells and they put it through a process, their neuron process, that basically separates the mesenchymal cells from the other kinds of cells, right? It kind of like purifies them, right? And so separates like fat and things of that nature. And then it takes the what they refer to as neurotrophic factors, the neurotrophic factors, and amplifies them. So basically what it is that these particular stem cells have these neurotrophic factors and in essence nourish, heal neurons or other kinds of cells. And what they're able to do is they're able to multiply these cells like by orders of magnitude. And more importantly, they're able to cryopreserve the cells, right? Which will be important for later. And I can explain that. So then they take it and they say, hey, sit down. Get on your side, and they do a spinal tap, a lumbar puncture, basically. And I've had that before, and it's not fun. It's no good, but it's not, if you're doing it in a reputable place, they do it well. And, but, it's the bone marrow aspiration. That's the painful part, really. But anyway, they squeeze this new, amped up, purified, stem cell into your spinal cord, right? So that it basically juices up with all of the cerebral spinal fluid. The idea is that those neurotrophic factors then kind of envelop the damaged neurons and bring them back to life. And it's working. So they did the phase 1. They proved it doesn't kill people, and they did the phase 2 trial. They did the phase 2 trial in 3 different hospitals. One at, I want to say, the Mayo Clinic, one at Mass General Hospital. Anyway, 3 hospitals. Who cares? All right. So, and they had, how many people were in that trial? 48 people, I believe, that they were able to include into the trial. And they were able to demonstrate, and I can give you more information, more details if you're actually interested, but they were able to demonstrate that with this application, I'm going to say majority, I'm not sure if that's the actual language that they use, but a lot of the people that went through the trial basically not only slowed down the progression of this horrible disease, but it was able to stop it and bring the functions back. In some people. There was a fighter pilot, Matt Bellina, that basically got ALS, fought for his country, got ALS, and he got the Neuron treatment because he fought for it. He helped pass something called the Right to Try law, which you may have heard about in the news over the past several months. President Trump is making him, not making a big deal out of it, but he's pointing it out. He's something that's proud of, and I'm proud of him for doing that too, for saying, hey, yeah, if you look it up, Right to Try. It's basically saying, hey, look, man, if you're dying and there's a drug that might kill you but might save you, you have a right to try that drug because you're going to die anyway, And so he took that drug, Matt Bellina, and he went from being confined to a wheelchair for 2.5 years to being able to, walk, work out, bike ride. Another guy, same exact thing. I'll put some, if you're interested, I'll put some links to videos where you can see people who are coming out and saying, hey, it's working. It worked. But there are a lot of complications involved with what's happening, right? The major one being that, for whatever reason, we I'll say a science community, as a country, haven't been able to get our act together on this. But it's just, this is the crux of the issue, is that ALS is the only remaining incurable disease that, because of its severity, the Food and Drug Administration requires a double-blind placebo, a 1-to-1 randomization, which is basically like saying, look, here's how it's going to go. We're going to recruit 200 people, right, who have a very specific criteria. They have to be under 60 years old. The onset of the symptoms should have began about no more than 24, 25 months ago. You have to be able to breathe at a particular level, because a lot of ALS patients, again, sadly, the way you actually die is you suffocate, because you lose your diaphragmatic muscle. So you have to be able to breathe at a certain level. So what happens is, if they recruit those 200 people, but because it's a 1-to-1 randomization, 100 people will get the treatment and 100 will not. They'll get a placebo, which basically means they'll get water. When they're injecting the thing into their spinal column, it won't be the Neuron treatment. And it's 3 lumbar punctures, and it's 14 visits across a 9-month period. Each one of those lumbar punctures, risk of infection, risk of paralysis, risk of death every single time, and not to mention the bone marrow aspiration, which basically makes you feel like you got kicked by a mule in the back for a couple of days, I've never had a bone marrow aspiration, but that's how I've heard of it. I've heard it ain't fun. So imagine sacrificing at great cost. Imagine all the people from all around the world that start flying to Boston, or flying to, having to come to, you have to foot your own bill for travel. You have to foot your own bill for everything, really. They'll foot the bill for the procedure and the drug, but you have to foot the bill for doing it 14 times, So it's a real sacrifice, man. It's a real sacrifice. And after you do it, you don't get it? Imagine that situation. How is that ethical even? In fact, they've stopped doing that for cancer. I learned from this guy, Mike Hansen. He was saying that what he has learned is that they don't allow placebo drugs in cancer research anymore because they consider it to be unethical. People are dying and we're doing placebo trials. Well, the mother of all diseases still requires 1-to-1 randomization. Nonsense, right? So, that's why we're trying to raise some money We need to raise some money because there are other promising stem cell-like procedures that are being done in Israel, China, Mexico. And these are, I'm talking about legitimate places, like major hospitals, right? I'm not talking about like, the little strip mall that says, hey, gene therapy for low price of $25,000 will fix your incurable disease. I'm talking about major doctors. I'm talking about major institutions, like the Ichilov, in Tel Aviv, major medical system, world renowned. And in fact, what I learned is a lot of these places that are offering these neuron-like treatments are actually housed, most of them by American doctors. Apparently the ones in Mexico are almost completely American doctors. So, but you got to foot that bill, right? And it isn't a one-time shot, right? These treatments slow down the progression, but once you stop the treatments, the progression starts back up again. So our plan isn't to just create a funding stream so we can, take Olga to Israel so that she can get these, treatments. No, our plan is to buy time. It's to buy time because, based on my research, my interactions, the interviews I've done in learning about what we're going to do to save my wife's life, I've come to learn that, the FDA is going to approve this Neuron thing. And my best guesstimation right now, being July 1, 2019, is that the enrollment for the phase 3 trial will conclude by the end of summer, which means that it's at that point, I think, if I'm not mistaken, that the Brainstorm organization can actually apply for final approval. And then it'll take about 11 months to figure out the data set and analyze it, break it down and say, look, here's why it works and here's why we're changing the world. And then there'll be an open comment period, of course, and then it'll go to market. And so my best guesstimation, based on what I've heard from other people as well as from the CEO of Brainstorm, is that in this time, 24 months from now, this thing is going to be in the market, This thing is going to be available, God willing, at Kaiser, at Scripps. It's going to be everywhere. It's a complicated issue, though. It's a very complicated issue. So we need your help, friends. We need your help in multiple ways. If you can donate, fantastic. If you can't, I understand. But maybe you can do this for us. Maybe you can help Olga by advocating for reform. And I'll do all the legwork for you. I'll give you the email addresses. I'll give you the letters, the form letters. I'll give you the addresses. Phone calls and letters. That's the trick. Emails work too, but emails delete, right? Or reply with a canned response, right? It's pretty hard to ignore a phone call, though, right? It's pretty, well, I do it all the time. But, people calling you talking to human beings, if you just call them and just read something out, I'll write the blurb for you. Or if you're willing to mail something to the people that I'll send you information, that would be very, very helpful. We're working, not we, but there's an advocacy group that's working towards, making some moves here, hopefully in the next couple of months. But the FDA needs to hear from us. Donald Trump needs to hear from us, and the specific people that need to hear from us. Again, I've got all that information, and I'm going to send it all out to you. So what we need your help with, my friends, is to help save this woman's life. Basically, we need help so that we can come up with enough money to be able to take her to get alternative treatments in other countries. Until hopefully this Neuron product gets approved. And if the Neuron product gets approved, and there's other product too called copper ATSM product that's in phase 2 trial. It's about to start this summer. And that has been shown to do even more miraculous things. If, the Neuron procedure coupled with the QATSM procedure, coupled with a, T-cell regulation procedure that I can talk about later. It's a cocktail. It's like 3 things that is going to help us cure ALS. It's going to help us stop death. And so I need your help. If you can, please give some money. If you can't, no worries. Just help me get the word out that we can save people's lives, you guys. 20,000 people get diagnosed. There are 20,000 Americans right now that have ALS, at least, and thousands that are dying every single year. Like every 90 minutes, another person dies from ALS, and it is a terrifying, terrifying death. We're not talking about getting hit by a car. You know, that's tragedy too. I'm not downplaying that, but that's in an instant, right? And even though it's going to be a lifetime of heartache for the people that lost their loved ones, you know, the person who died in an instant. ALS doesn't work like that, right? You just slowly lose everything until you're basically a marionette sitting on a chair. So we got to help reconnect these wires to these muscles. We can do it, and it looks like it's possible now. It's not an oil. It's not, you know, we're not, you know, homeopathy is going to be important. Good nutrition is going to be really important. Of course, you know, that stuff is the basis of life, but this stuff that I'm talking about is magic. This is the real stuff. And I want my wife to be the first person to survive ALS, and not only survive it, but to regain her functions. And you can help us do it.